Do you know the difference between a voltage and a current on an X-ray tube? If you don't, or if you want to learn more about it, tune in on this video because we're going to be discussing what is the function of the voltage in an X-ray tube and the current. One question we get often quite a bit is, what's the difference between a voltage and a current on an X-ray source? And that's actually a very, very good question. Let's take a look at our schematic of an X-ray tube right here that we have on the board. The X-ray tube has two main elements, an anode and a cathode. And then you have the filament and the target. Right, so pretty straightforward. Starting with the filament here on the left. And by the way, this whole thing is sealed in vacuum. So there's a vacuum tube that keeps everything in a very good vacuum. And if there's any air in here, this thing is gone. So the filament on the left is much like an old Edison light lamp, right? That has a filament, warms up and generates light. In this case, this filament is going to be warmed up to generate free electrons. Those free electrons are caused by the heat on this piece of tungsten wire. It warms up and those electrons go out of their shells and now they're available to be deployed. And then what we do is we put a very high voltage, thousands of volts between the filament and the target. And that, with a positive here, so these electrons see this very large differential potential and they just depart the filament towards the target. Once they hit the target, they knock electrons from the target's atoms, and with a process called brainstorm radiation, those electrons, after they're retreated from the shell, as they recoil, they emit an X-ray photon. Right in that X-ray photon, then we put a window here on this tube, and that's where the X-rays exit the tube. Current is right here. So the current on an X-ray tube is the amount of electrons that you're going to be producing in a unit of time. So how many electrons you're going to be producing in a second, right? So it has to do with this number of electrons that are going to hit the target. The voltage, and again, we're looking at voltage and current. The voltage refers to this differential potential that we put between the filament and the target, which has to do with how fast those electrons are going to hit the target, and as a result, how much of that recoil radiation we're going to have, and how energetic those X-ray photons are going to be. So, to simply put, the voltage on an X-ray source has to do with the energy of those X-ray photons, and the current on an X-ray tube has to do with how many of those photons are going to be generated per second or per minute or per hour. So there's more information on that in our X-ray inspection book on page 10 if you want more details, but essentially that's what it is. X-ray current is how many photons we're going to be generating in an X-ray tube, and X-ray voltage is the energy of each one of those photons. Hope this was helpful. If you have any other questions, let us know. And for more videos, more information, don't forget to subscribe.